Can you see it? Yeah, everyone can see it. Beautiful, excellent. Well, hello everyone. My name is Mike. I'm a product leader and technical product manager. At the moment, I am the CPO for actually a bunch of companies. I'm working as a fractional CPO for an organization in San Francisco called Exploding Gradients. Some of you who've been working on AI tools might know the AI evaluation framework Ragas. That's the stuff that we are making. I'm also keeping it local. I'm working for a wonderful organization, probably the best bunch of people in the technical space that I've ever had the chance to meet here in Queensland, which is called Odoguru, helping them with the AI journey. And in my free time, I like to mentor for our wonderful River City Labs ecosystem that we have here from an entrepreneurial perspective. So that's a little bit about myself. I also don't want to stand in the way of lunch. And while we just had the opportunity to witness really two beautiful presentations, thank you very much to the previous presenters and the organizers, of course. Right. What I'm going to do is I'm going to keep this relatively light and a little bit interactive. So the first thing that is going to happen is I'm going to tell you a little story in order to demonstrate something. And the story that I'm going to tell you is about a gentleman called David. I'll tell you a little story, and then I'm going to present you with 8 scenarios that I want you to rank according to what you believe is applying most probably to David. So it might be a good opportunity to take out your phones or any note app that you might have in order to help with that ranking here in a second. And that way we can get started. So here is our little scenario. David is 33 years old. He's articulate, thoughtful, and curious. In university, he majored in political science and spent much of his time organizing events related to climate change, economics, justice, and digital privacy. He often spoke at rallies and was involved in several grassroots campaigns promoting ethical governance and community empowerment. So what I want you to do is take that away and form a little picture in your mind about the person that David is. And now I'm going to present you with these 8 little scenarios, and I want you to go ahead and rank them in order of what you believe is most probable. And then in a second, or in a couple of seconds, maybe I'll give you a minute, right? After you've ordered them, right, I'm going to ask you for the results. Brilliant. Stuff. Some people are working on their phones. That's great to see. Excellent. I'm also sort of glancing over here on the side. Brilliant. Maybe give you another 10 seconds. And then I'm going to ask for the results. And again, this is to demonstrate a particular dynamic that we're going to dive into here in a second. All right. Good. Quick first question. As an exercise, see whether everybody paid attention. Who ranked the scenario that David is a high school teacher first? Please raise your hand. Yeah, you did. Wonderful. Excellent. Perfect. Who ranked that David is a regular contributor to online forums about public policy in the last 3 spots? Wonderful. 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 Excellent. Perfect. None of these choices matter up to this point. We just wanted to exercise a little bit so that we can, you know, deserve lunch. No, what actually, here's the actual question that mattered. Who of you ranked point H, so David works as a bank teller and is involved in political activism, higher than David works as a bank teller? Please raise your hand. Wonderful. A lot more hands going up, huh? 1, 2, 3, 4, 5. So half of the room at least, right? This is very congruent behavior. As a matter of fact, this is a wonderful little experiment. Sorry, show of hands. This is a wonderful little experiment that was conducted in 1980 by a gentleman called Daniel Kahneman. He is a Nobel Prize winner for seminal work on defining what we are now terming System 1 and System 2. Some of you in the AI space may have heard of those modes of thinking that we apply to our brain. What you've just experienced is this cognitive little experiment which highlights a particular defect that we all experience with our system one thinking, and that is called the conjunction fallacy. What just happened is, and again, 89% of people who have taken this particular test had the same experience, is that when we are faced with a conjunctive proposition, so two or more events happening at the same time, our system one, our intuitive brain, will think that this is a higher likelihood than the individual event happening on its own. The reason why this happened had something to do with how I posed the question, because I asked you to paint a little picture of David in your mind, right, when I told you that little story. And what you then did was you created a representation space against which you evaluated the various options that I was able to share with you, right? And that's why you then went ahead and compared those little facts that I shared with David, or the scenarios, against, in terms of what is more representative compared to the story, rather than what is actually more probable. Because if we look at probability, the fact of the matter is, mathematically, right, David being both a bank teller and an activist has a lower probability than David being a bank teller, right? Because there's way more bank tellers that aren't activists, right? They have lots to do on the weekend, right? Good stuff. So why does this happen? Well, as I mentioned before, it's a consequence of our system one and system two thinking, but I'm giving you this context because we're going to jump to the AI here in a second. But essentially, the way our human brains work is that we have an intuitive side, which is usually the thing that allows us to operate in situations where we do feel cognitive ease, where we're not threatened, where we do not have the need to really engage our brain in order to apply it to complex problem solving. It is sort of the thing that happens unconsciously and allows us to intuitively make judgments based on situations or facts that we are provided with, right? System two is a little bit different, right? System two is the thing that we're engaging when we deliberately need to solve a particular problem in a really controlled way, right? It supports our complex decision-making, our complex problem solving. Now, why am I telling you all of this? Well, over the last couple of months, I've spent a lot of time thinking about, reading into, and actually researching instances where our beautiful memory association machine, which is our brain, might jive with the beautiful memory association machine that are LLMs, but where they either get it wrong on both sides and they don't know it, or where one is out of sync with the other, and both of those situations can cause negative user experiences, right? To give you an example, right? This is DeepSeek. We asked DeepSeek the same exact question, and it came up with the same judgment, right? Obviously wrong, but nevertheless, this fallacy applies to both human brains and AI-associated memory machines. Awkward, sorry. Gemini 2.5, the same. But don't fret. OpenAI 4.5, latest model from there, had the exact same problem. And Claude 4, which I believe was only released 2.5, 3 weeks ago, same exact issue, right? So now why does this matter? But it matters for the design of AI applications and specific business applications in various ways. We do have a lot of use cases where AI and humans are dealing with conjunctive statements that they then need to evaluate in order to either make a prediction or provide a specific result, right? Give you a couple of examples here: fraud detection in e-commerce, credit risk scoring, healthcare triage, and CV screening. Right? Now, you might say, okay, these are some theoretical applications of this. Where's the proof? Well, so one of the little case studies that I ran was we essentially generated 100 triplets of resumes that we designed a specific position description for, and asked our beautiful large language models to essentially rank in order of which CVs tend to be the most suitable for that particular position, right? The CVs were mostly identical, except they were specifically designed with two attributes in mind. One was suitability. So as you can see, Jordan Lee Green at the top. And by the way, sorry for anyone who's colorblind, I should have thought of that. So Jordan Lee would tend to be the most suitable candidate if we compared it with the position description, right? But it is also the candidate that contained the least amount of conjunctive statements in their resume, right? There were more conjunctive statements in Casey Jones' case. Suitability was sort of okay, right? Riley Morgan, probably a stretch, but the most amount of conjunctive statements that we had, right? We ran this test several hundreds of times, and here are the results, right? And then I thought, okay, well, it's not necessarily fair to do this, right? Because these are foundational models, right? They aren't necessarily designed for this use case, although it is a very powerful, powerful, frequently used use case by more recruiters than you would like to admit. But I also went ahead and evaluated it against an application that was specifically designed to do nothing but CV scoring. And what's the name here, right? It is a startup that is operating in this space, but even then they got it only half wrong, right? So very, very important. And this is not the only fallacy that we're dealing with in this space, right? We've talked about the conjunction fallacy, could go on for several hours, but we do have lunch to eat, so that's more important. But we're also dealing with things like anchoring, right? In an experiment where we essentially took the SciMed database, which is a publicly accessible database, and we asked our models to essentially triage patients for sepsis, right? Given a number of physical measurements and parameters. If we've changed the first temperature measurement to 42 degrees Celsius, let's say someone made a typo, right? Across, I think it was 10,000 records, right? We saw an average of a 47% increase in false positive and a 58% increase in false negatives, just because of anchoring, right? You may have the first temperature reading of that patient who came into the hospital to be 42. The remaining 58 ones were all 36, 37. Everything was fine. It didn't matter. They would still be diagnosed with sepsis. Very, very important use case, right? And then we have confirmation bias and overconfidence. And then the question is, of course, well, how do we control for this, right? So there are a couple of control measures here that I mentioned here in the last column, right? Very important, other than looking at training those models with actual statistical and probabilistic modeling, which we as business application developers have very little influence over, right? There are a couple of techniques that have proven really useful, right? Specifically for the conjunction fallacy, decomposition of conjunctive events has had 100% success rate in not falling victim to the conjunction fallacy in the CV evaluation use case that we ran, right? Similarly, confirmation bias, right? Agentic orchestration, where you have different agents represent different perspectives, right? Or parallelization, where you ask the same question to various models and then you bring the perspectives in and have an aggregator run through those two. And here's, I guess myself, we do not have evaluative models in place at all for these, right? For anyone who's worked on AI business applications, the way evaluation usually works is you, before you send your application live, you create 100 files. These are all English language prompts that you are writing or have automatically generated. You send them off, they come back, and then you ask another LLM to compare the response that you received to a ground truth that you have given, right? And that ground truth might be, okay, for this question, I want this answer, for this question, I want this answer, but it's another LLM that evaluates it. And so you can see the inception qualities here, right? Which is, if I am falling subject to the conjunction fallacy, and the LLMs are falling victim to the same conjunction fallacy, right? My evaluation model won't work anymore. And so these are the kinds of things that will help us keep track of those particular vulnerabilities. Very, very important, right? If you are a business that is working on a business application, this is the last slide, I promise, right? It is very, very important that you consider the unique process that you have established as a business in order to solve the business problem, right? You are the best at solving that problem. That's why your business has a justification to exist, right? And not just outsource it to the AI, right? You break it down, you turn it into a very defined incremental atomic workflow. You test it through evaluation at every single time. Then also very important, when you design your application, prompt for quadrants of uncertainty, right? And orchestrate for perspective redundancy. Parallelization I was just talking about, right? Making sure that you get different perspectives for the same response and then aggregate it to bring it up. And that should significantly reduce any false positives or false negatives you get due to bias concerns. And that's it. Do we have any questions? No, everyone's hungry. Excellent. Yes. Mm-hmm. Yeah. Yes. Yeah. 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 Oh, well, no, you're striking at sort of the heart of the AI evaluation problem, right? So for anyone who hasn't worked with artificial intelligence before, I brought my wife. She's in the case, so I think this is for you. Essentially, what you do is you're recognizing in your statement just now that we're working with non-deterministic systems, right? So responses that you can get back, you cannot predict, right? They will be, as a matter of fact, they will be different every single time. So the way we are working with this in the evaluation space is the first couple of approaches we're centering around two principles. One is ground truth. The other one is having LLMs evaluate the work of other LLMs. So what you do if you are building a large-scale application, right? Let's say you created Gemini 2.5 yourself, right? Yeah, or the agents or a business application. Let's say you built a business application such as yours, right? When you are asking them to create that beautiful plan for you, right? What you don't want is to create 20% of the plan, then follow up with like 25 cheesecake recipes and continue with the rest of the plan, right? You don't want that. It would be fun, but you don't want that, right? So what you do is you essentially create a number of test cases. Let's say you asked it 500 times, you ask your system 500 times to create you one of those beautiful reports, right? And then you get all those 500 generated reports back, and then you compare it to the ground truth. And your ground truth might be a sample report that you have created, a sample report that might. Oh, that is exactly what I mean here, right? About your unique process, right? So in order to teach an LLM application how to build the best civil engineering reports that there are automatically, you need to have, right, someone like Derek, who's a subject matter expert in the civil engineering space, in order to know what good looks like, right? And then you are augmenting your prompts and your orchestration and your input data. Talked about RAG a little bit before, right? In order to get to that outcome. But because you need to get to that outcome at scale, with evaluation, you need to use evaluation frameworks that allow you to essentially do that 500 times and then get a report back and said, okay, out of those 500 reports that you asked me to generate, maybe 2 or 3 or 4 didn't meet the mark. The rest looked really good, right? And that's how that generally works. Did that answer your question? Yeah. Yes. Yes, exactly. The a framework, yeah, such as Ragas or DeepLR. Yeah, that's correct. Correct. Good stuff. Excellent. Yes. Do you have another question? Oh, different answers or the same answers? Different answers to the human. So in this case, the LLM actually responded exactly the way we humans responded, right? So it had the same bias that we had. And the reason for this is ultimately because LLMs in their beautiful memory associative machine is a lot more similar to our system 1 thinking than a system 2 thinking. That changed recently with reasoning models, so keep that in mind. But still, it isn't as complex as the way our human brains work, right? So in terms of asking the LLM to make a judgment for this particular fallacy, right? It essentially fell victim to the same representation space that we as humans fell victim to. So it looked at the story, it built itself a little reference picture of the memory as to what David would look like, and then it referred to the reference picture rather than the statistical probability, right? Does that make sense? Wonderful stuff. Any other questions? No?